Okay, yeah. So YouTube streaming has started, and this is the link. I just pasted in the chat. So this is the link for today's session. Let me also share my screen. One second. Okay. Yeah. So I am not going to make you to open some peer decks or anything. As week one, I felt ki it's more like let's do it in a more like interactive solve with us session. So while reading the question itself, we'll all discuss about that question and we'll move on to the next question. Okay. Maybe I'll give you time, but I don't want to collect that particular data of how many are giving you, how many of you are giving correct or how many. So let's start again. Okay, my name is Srikanth Venkateshan. So I'm a course instructor for Statistics 2 and MLF. And this is the very first time I am doing MLF as an instructor. Let's see. I think this particular term, even I will learn many things, and you teach me, I teach you. So we'll just do knowledge transfer between us. Okay. So let's move to the very first question I have today. So it says Arun goes for a walk on a daily basis and records the number of. So, oh, I hope my screen is visible.
Yes, sir.
Okay. So Arun goes for a walk on a daily basis and records the number of steps he has covered on each day using pedometer. The following table shows the recorded data for a week. So he wants to know how many steps he can cover on the next day. So this is the situation we have now. And my question is, which ML model is more suitable here? We have seen many ML models in week one. So can someone name
Where did you
few?
source this problem from?
Hmm?
Where did you source out this problem?
Source?
I mean, is it the practice exam, practice assignment, or it is a graded assignment?
So I will just cover graded assignment questions also, but it's like week one question. So what I expect from this question is you just have to know if you are
No,
given
no,
any
no.
situation.
The
Yeah.
purpose of this question is: do we need to have some copy the question also, or just it's somewhere else it's there?
Can you repeat? Sorry, I didn't understand.
Now, once we are discussing it in our class notes, I mean, if someone is taking the notes,
Hmm.
should they need to copy the problem, or it is already available in the website?
No. It is not available, but anyway, we will share the slides right after the session.
Okay.
Okay. Yeah. See, this is more or like solve with the slides only. So these slides will be shared to
Where
you.
you share the slides.
Okay.
Maybe in the supplementary contents, right? The usual place.
Okay. Got it.
Okay. Yeah. Uh, did someone join from the outside the domain? If you have joined from your personal IDs, please do join from the student IDs.
So I wanted to ask what do you expect from this session?
Your voice is pretty low, Mohammed. Yeah.
Sir, I'm saying what
Huh.
do we expect from this session today? Like what are we gonna do?
So we are going to solve few problems, and among those problems, few problems will give you some ideas on how to solve graded assignment questions.
Okay, fine.
Okay. Okay. So let's proceed. And yeah. So I'm asking you, what is this ML model means, and what do you know about machine learning models, and how many models have you seen so far in week one? So can someone name few models?
So basically, model is a mathematical simplification of reality. And there are two types of model. One is predictive and other is probabilistic. And in predictive, there are two, regression and classification.
Hmm. Okay. Yeah. So you have got some idea about what is a model, right? Like it's not the formal definition. So I want crude, like maybe some layman terms. I just need. Did everyone got what if you hear model? So machine learning model. So I want
Model
the
means
yeah,
it's like a function. We put something and we get something from the second side.
right, right. So models are basically just the see in reality all the data. If you wanted to understand the data or if you wanted to simplify the data, and if you wanted to simplify that and show it to someone or anyone, like if you wanted to present your data, these models are very much helpful. And this model, not only model is one way of representing your data, and model is basically a mathematical formula. Okay, so it is very simple understanding that model, if you hear about a model, so that means it will it is nothing but a mathematical formula. So some examples you might have seen in the lectures also. So we have gas model, which is PV is equals to nRT. So that is one model. So it gives the relationship between pressure, volume, and temperature. So like this. So it is nothing new. It's just the mathematical formulas, and this will simplify your data, realistic data. Okay, now tell me. So as someone explained many models like regression, classification, and predictive, probabilistic. So which ML model is more suitable for this particular problem or this
Regression, sir.
particular
Regression.
situation? Regression. So do everyone agree with this?
Sir, I'm not
Yes,
quite
sir.
sure what is regression. It was not clear in the session.
Ah,
Maybe I have just missed. Can you please tell me this?
okay. So those who have answered regression, so many of you said it's regression. So those who have answered regression, why this particular scenario can be fit into regression model?
So, because giving us a numerical value. We
Because
have
you have to predict something and numerically.
yes.
Right. So one thing is in regression models are basically used for predicting data. And in that predicting data, if your outcomes or outputs are reals, output is real. So that means if you see here, number of steps is your data. 5,800, 5,945, 4,880. So these all are real numbers, numerical numbers, right? So if you want to predict something, and if you have one feature or outcome, if your outcome prediction is somewhere real or continuous, so you can use this regression model. So that's where this regression.
Also, like we are training the model with labeled data, right? So it's supervised. Like we
Yeah,
have
it's
the
supervised.
previous days
Correct.
values.
So as you brought supervised into the picture, so regression model is a supervised learning model. So we have two paradigms of machine learnings mostly. So machine learning is mostly cut down to two paradigms. One is supervised learning and another one is unsupervised learning. So usually every model will be either supervised or unsupervised. Okay, so that is how you should understand. So if a scenario is in front of you and you have to predict which model is best suitable, So if you know what regression model is, what classification model is, then it is very easier for you. By looking at the data, it will be easier for you to predict which model can be put onto this data and then draw the conclusions. Okay. Any doubts? So this answer for this will be regression model.
But here, for example, if you go by the trend, 5,800, 5,900, if you see on 5th and 6th, they are having 5,800 and 5,945. If you take this as the data reference, obviously on 7th you will be just come somewhere around 6,000 because 8th is also 6,000, 9th is also 6,000. So if you attempt to predict anything on the 7th, you are not going to get 4,000, somewhere around 4,000. So this model is not going to perform. And
on that particular data point.
Similarly, on 10th also, it's not going to perform.
Yeah. See, you are talking about a particular data point, right?
Yeah. I'm telling about the reliability of the model.
Also, no. See, not always regression models are linear models. Okay. So you are thinking that if you put this on a linear model, then whatever you said, 7th and 10th will show a huge error.
Yeah.
And if I want to be better, if I want a better model, I will not be going to a linear model. Maybe I will go for polynomial fit.
It doesn't fit in that also, no, because it is just
it can fit, right? Like polynomials give you that freedom, right? So the graphs of polynomials, if you remember, it will be somewhat like this.
Yeah, that's right. So there is no cyclical pattern here. No, so you mean to say that every 2 days this guy is getting tired and
maybe that you can predict, right? Like, so if this is the trend, that at least that you can predict, right? Like every 3 days, every third day is going to walk less than 5,000 or yeah.
Okay. So
Okay. So now using that,
that's a pattern recognition. No, it's not a regression.
From the graph also you can get the same thing, right? See, also this data points are very less. Okay, if you wanted to predict, it's like
no. What I am leading to, it is not necessarily regression. It could be pattern recognition also, no?
Pattern recognition. So is there any model called pattern recognition?
No, I am just asking because here regression means it should be an equation, is it?
Regression, yeah.
It's an algebraic equation.
Yeah.
At the end of the day, but here from going by analyzing the data, every third day this guy is having a sort of a drop in his effort.
But that is not what we expect, right? What we have to answer in this particular question is how many steps he is going to cover in the next day. So you have to predict it. It's not analyzing that. You are not analyzing the data. Instead, rather you are asked to predict the future.
Yeah. For that one only you are deciding about the model, no?
Model, yeah. So in order to predict, so I will analyze the data along with I just have to predict also, right? Like what happens tomorrow.
Okay, let me wait until you finish that one, because
if
you go by regression, you might be getting one answer. If you go by pattern, you'll be getting a different answer. Let's see that one, how it's coming up.
Okay.
Yeah, I'll stop here now. Just continue.
Sure. So, okay, that's the thing I have for question 1. So I just want which model is more suitable. Okay. So I am not saying that the only model which is suitable for this particular scenario. I just asked which is the more suitable, and by looking, see here we have to predict the data, and looking at the output also, what we are going to predict, it's a real number. So it's the number of steps may be numerical number. So if it is numerical and predicting data, it falls under the regression model. So in regression model, we are going to predict the data and the output is a real. Okay, so let's move to one more scenario. Now, behavior analyst decided to study the emotional state of his spouse at the end of
You
each.
are not going to find the value for that one. What is the number of steps for?
No. I'm not going to find value. I just asked. I just want which model is more suitable here. That's it.
Oh, okay. So that's all the answer.
Yeah.
Model.
So
Okay.
that's all I wanted in this.
Okay.
Okay. So computing and all. See, nowadays, once you fix the model, everything is readily available for us, right? The
Okay.
only challenge we are still facing is when you are given some data, or when you are in a given some scenario or situation. So if I ask you to predict or analyze the data, which model are you going to use in that situation? So that cannot be done. So that can also be done using AIs, but that is the maybe that is the most difficult part. Okay, computation and all can be done, and it's all well defined as of now. Okay, we will also do computations in the later questions, but let us do something like this in one more question. Okay. So, yeah. So in second question, a behavior analyst decided to study the emotional state of his spouse at the end of each day. He decided to observe and record various events. In our machine learning terms, it is called as features. So each column is represented as feature in data. So that happened to her on a daily basis. The table below shows the data collected over a week. Which ML model would you suggest him? So this is
Classification, sir, I guess.
okay. So classification. Okay. Any other answers?
Yeah, it's classification, sir.
Okay. So do everyone agree for this?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah. Okay. Now tell me. So maybe in this, I just wanted to discuss few computational part also. Okay, it is classification. Okay, because again, see here also, if you see you are what we can see, you are on the 12th. You wanted to predict her state of emotion. Okay, this is also you have metadata inside this, like what all the data is provided to you, and it also comes under supervised learning. So supervised learning, and your output is not a real number. So your output is classified into some set of three here. So happy, neutral, anger. Okay, so it's like this. So it's not any, your output is not real, or maybe prediction. So your prediction is not a real
Sir, it
prediction.
could be discrete, -1, 0, and 1.
Yeah, that is a discrete output, and this is also predicting data. So if you are going to predict data and your output is not real, sorry, or your output is discrete, let me put it in this. If your output is discrete, then the best model or more suitable model will be classification model. So you just have to classify. So if she gone for shopping, housemaid is present, gone for walking. So if all these three happened, so if she's happy. Uh, can I request everyone please be on mute? Okay. Now, similarly, if housemaid is not present, she is neutral, but she gone for shopping and gone for walking. If more than two is not happening out of three, she is very angry. Like you can observe it on 7th, 11th. But there is one more error Like on 10th, if you see housemaid is not present, she didn't go for walking, but she's happy on that particular day. So that's how the emotions work, right? It will not work. If it is work for one day, it won't work for the other day. So like this, if this is the situation, so in this kind of situation, we wanted to predict her state of emotion. Okay, and state of emotion is a discrete thing. Either she will be happy or neutral or anger. And predicting data and discrete output, this falls under classification model. So you can fit this data into classification model and predict accordingly. Now, so someone said, so I can create a function algorithm which takes the inputs, maybe I say features, to someone said -1, 0, 1, right? How do you come up with the loss function?
Happy.
Loss function. Okay, tell me loss function for this binary classification. So whatever we are
-1.
going to see is binary classification only. So what is binary classification means? So whatever you have seen in the lecture.
So we will have to calculate the loss for all three states, right?
No, binary what is the loss function for binary? Yes,
0.
0.
It's 1 over n, then summation of basically the one function,
Indicator, right?
indicator of the
Indicator.
not equal to.
Indicator of not equal to. And how do you define your f is basically sign. It takes a sign, right? Sign of something, right? Either you take +1 or -1 depending upon the value you get.
Excuse me.
Hmm.
What will be the sign of 0?
So that's the point. So you cannot use, so if it is this, so this is called multi-class classification. So it's not binary classification. This is called multi-class classification, and this falls under logistic regression, so which you are going to see in future. Okay, as of now, in ML foundations, if it is classification related problem, either we will be asking you whether the number predicted is greater than 3 or less than 3, or yes or no. So you will only see the binary classification. So you won't be seeing multi-class classification, and this falls under multi-class classification. But it is very good to understand that at least you are able to predict which model you are going to suggest. You shouldn't suggest him regression model on this, or density model on this, density estimation on this, or maybe dimensionality reduction also. Okay, so that's the key point I want to make here. So you have to suggest him the classification only, but not the classification which you learned till now.
Sir, would we assign -1 for anger, 0 for neutral, and 1 for happy?
-1 for
Anger.
anger.
Something like that.
You can put, but coming up with loss functions, and see here loss function is maybe summation I is equals to 1 to n. This is indicator of this f of xi not equals to that yi. Okay, so something you can do for binary classification, and you can also define your f of xi as sign of this, either +1 or -1. So what will, if so you have to come up with that particular function. How do you define your function now? Okay, you have taken inputs. So what should be the function such that I will get -1 for happy, 0 for okay, -1 for anger, 0, 1. So I have to get all the three outputs, right? Coming up with those kind of functions.
We have to make a different model for this kind of a question.
Right. So it comes under classification only, but not maybe logistic regression is the best model for this, and the loss function is I don't know how many of you know this. It is cross entropy. It is going beyond ML, right? Okay, let's not go. If people know about this cross entropy, just go back, search. And logistic regression uses cross entropy, and we will classify using that class. By getting lesser cross entropy, we will reduce the, using the loss function, we will try to reduce the cross entropy and get the best model. Okay. So
Sir, here we cannot use sign function.
No. Here you cannot use sign, because sign for 0, you will get outputs always -1 and 1 only. You won't get 0 at all if you use sign. Right. So sign you can use for binary classification. Okay. So let's not go beyond. So the key takeaway from here is, if you see, if you are going to predict the data, as well as the output is a discrete output, maybe it can be more than 2 also, even though it is even if it is discrete and you are going to predict the data, then that falls. So the best model you have to put for that particular data is classification model. Okay, so that's the only key takeaway from this particular question. Okay, so let's move. If there is time, we can move.
Sir, there was a question in activity question. So the question says that for the regression model, it takes the continuous value, but the continuous is finite or infinite or something like that. The question was.
Continuous is always infinite only, right? So if it is continuous, means it has infinite number of reals inside. Okay. So is it in activity or graded? Are you asking me graded questions?
I don't know, sir. I think.
Okay. So I think it's a graded question. So it's like regression. What is the output of a regression model, right?
Yeah. Yes,
Real
sir.
or
Yes, sir.
discrete, or real with
तोर फोन वही घर में छो
what?
Yeah, it's is continuous with any range, within finite range or something like that.
So that's if it is continuous, you can see, even if it is continuous for very small interval, there are infinite number of reals inside it. Okay, 0.01 comma 0.02 के बीच में there are infinite reals.
Okay, sir.
Okay. So it will be infinite always. Okay.
Yes, sir.
Okay. Okay. Let's move and let's do some computations also from now onwards.
फिर बेकार गेम
बेकार है man. Who is it? Okay, I just wanted to take, is it really Baker? So you can be open, okay? Okay, I know he will not reply. Okay, let's. Okay, I will try to make it more fun from now.
Sir, ignore him.
Okay.
We are enjoying it.
Okay. Okay, that's fine. Okay. Let's continue. So consider the following table that contains data points and their corresponding labels. Okay. So treat the third column, Y column, as the labels. So we are labeling each of the data point either with 0 or 1. Okay. So my questions are, the first question is, I just want all of you to plot these data points in the Cartesian coordinate system. And then the second question is, which ML model is more suitable here? And I also want you to come up with this particular linear separator and initialize the parameter values to 0.5, 0.5, 0.5.
So all x1, x2, y are features or label?
Y is the labeling.
Okay, sir.
So this is the label. and these two are the features. Okay, so usually it's like, see, x1, x2, x3, x4 to xn, these are the inputs, and y we usually represent it as output. Okay, so these will x's will be features and y's are the outputs. So first one done, like at least plotting to होना है, or else it will test on your maths on skills.
The Cartesian coordinates x1 and x2 will be plotting in the same axis, is it? And y is in another axis.
No, you don't have to plot y.
Oh.
X1 versus x2 it should be plotted, and y you can see that point, you can color or something, small point, big circle, small circle, some differential. Okay, done. So this is how it will be. So if you plot these data points, so you see I differentiated with color here. So blue represents the value is, the label value it takes is 1, and brown is 0. So if y is 0, I will label it with the brown color, and if y is 1, I will label it with blue color. So this is how it will be. Now tell me which ML model will be best suitable for this?
Classifications.
Classification. Again, you see, if you see the outputs y, so it is either 0 or 1.
Sir, it's numeric value also, I guess. 0 and 1 are numerical also.
Yeah, they are numerical, but it is discrete, right? It's not continuous.
Okay, sir.
So what is the color code you said? It is where zeros and ones, no? And y like this?
So, see this y. So these are just the label, okay? So if y is 0, one label. If y is 1, another label. So we have two labels here. If y is 0, I colored that particular point with brown.
No,
Y,
but there is y is 0. No. Two y zeros are there, no?
only one.
Serial number 1 is 0.
So
that is one.
All other threes are ones, right?
But number 3, right? Okay. All right.
Okay. So yeah, again you can see. So this is a function like this. It takes x1, x2s, and it will put either in 0 or 1. So our output is either 0 or 1. So this is a discrete output. And if it is discrete output, classification model is the best model that can be, that is more suitable. Yeah. Okay. Now the last question I asked is, come up with a linear operator, linear line. Okay, maybe this is a linear line with parameters 0.5, 0.5 and 0.5. Okay, it's like I have given you the line. Now draw that particular line on this coordinate system. Okay. So what I meant is the linear operator way. It's a linear line with coefficients as 0.5. So that means it will be like this: 0.5 plus x1 plus 0.5 x2 plus 0.5 is equals to 0. Okay. Now draw this line. So I have given it, Ritika. So I just want I just asked a linear line with coefficients 0.5, 0.5, 0.5.
Sir, why we have equated it to 0?
So that's how the linear line, right? That's a straight line, right?
Yes, sir. That's
General
straight line,
general
but
form of
we
straight
have
line. Yeah.
this is our model. You are calling it model, so it should be equal to
Yeah.
f of x some function.
Right.
Why we are equating it to 0?
Okay. In classification, we usually classify the things in binary classification. What we do, we separate both the labels separately, right? By using a line, right? Using a polynomial line or linear line, we will be separating them, correct? So like this, something like this, we will classify, right? This is the model.
Yes, sir. We will classify like this.
Below this,
Below it, we
it
will
will
consider something like
0. Above this, it will be 0. So I asked you, draw a linear separator with weights 0.5, 0.5, and 0.5.
yes, yes.
So it will pass in third quadrant.
Yes, correct.
Yes, sir. It will
So
be on in third quadrant.
third quadrant. So if you have drawn that, this is how it will be. So I said that linear separator and initialize the parameter values to 0.5, 0.5, 0.5. So this is how my linear separator will be. So is this a best linear separator?
No.
Good.
No, sir.
If that is not good, just find the loss of this particular linear separator and tell me.
That is 1/4, I think.
It has to be
1/4.
Yeah, 1/4.
Sir, how did you get this line and the third quadrant? Because it's not negative, right? In any case, the separate 0.5, it's not minus 0.5. So how did you get it?
No. If you simplify this line is nothing but x1 plus x2 is equals to -1. So if you just simplify 0.5, 0.5, 0.5, if you just, it will cancel out, okay? And this is the line which represents x1 plus x2 is equals to -1. So if you draw that line, that will come like this one. Okay. Yeah. So those
Sir,
who have
can you
computed
please?
the
Hello.
So why
Can you
cannot?
please tell me what is a linear separator?
So linear separators are the straight lines which separates the data into two halves.
All data.
So here we have 4 data points, right?
Yeah.
And three belongs to one class and one belongs to the other class.
Okay.
So a linear separator, what it does is that linear separator will separate this data into two classes. So one on one side and the other on the other side. Okay.
Fine.
So I said there is a linear separator. Let's suppose there is a linear separator, and you just initialize the parameter, like the coefficients of that linear separator are 0.5, 0.5, 0.5. Okay. So now if you just draw that linear separator which I gave you, so this is how the line will be. And my question is, okay, there can be many linear separators. Also, I can come up with this linear separator, and there can be like this another linear separator. Okay, so these all are linear separators. Okay, for this particular data, I am asking about this particular linear separator, and now I am asking you to find the loss of this particular linear separator. What will be the loss?
0.5.
0.5.
Yeah.
Okay, maybe option A 0.5, B 0.25, C 1,
0.25.
D 0.
0.25.
0.25. So as this is classification model, you know what is the loss function is, right? How do you compute the loss function? So loss function is 1 by
How many
n.
points are
4 points, right? We have 4 points. So 1 by n, so that will be 1 by 4. I is equals to 1 to 4, indicator of f of xi not equals to yi. So now if you see, what is the f of xi value? So f of xi is 0.5 x1 plus 0.5 x2 plus 0.5. Okay. So for the first point, it will be 0.5 times 0 plus 0.5 times 0 plus 0.5. So the whole will be 0.5. And sorry. For classification, we just have to look at the sign, right? I just have to look at the sign of 0.5 x1 plus 0.5 x2 plus 0.5. So now if I substitute the zeros, the first point is 0 comma 0. If I substitute it, 0.5 times 0 plus 0.5 times 0 plus 0.5, it is 0.5. Okay. So now what will be the sign of 0.5? It will be plus 1. So for the first point, we got plus 1, f of xi as plus 1, but y1 is 0. So both are not equal. So the indicator function will give us the value 1 for the first data point. So this will be 1 plus, for the other things, if you just substitute 0.5 times 1 times 0 plus 0.5 times 1 plus 0.5, everything is positive or greater than or equals to 0. So it will be, sign will be plus 1 and y2 is also plus 1. So the indicator function is 0. Similarly, for the other two cases also it will be 0. So you will get 0.25. Okay. So that is how you can compute the loss function for a classification problem. Now once you compute the squared this is 0 1 loss. So if you compute the 0 1 loss, see this is how it will be. So it should be like this. So this is the sign of each data point we got using this particular linear separator. So the sign is one for all the data points, but actual data shows 1 for only 3 data points and the first data point is 0.
So
So that's
by
where
anyhow, if we get for the serial number one y prime to be 0, then our answer to be will be equal to 0. I see. Squared error. So or it should be negative too.
It should be
Negative means in the question that we see in the lectures, we get the -1 and the 1 as the range for this kind of a functions. But in this question, we have 0 and 1 as the range.
right.
So if we get for the serial number one, uh, if we get y prime as 0, then only we will get 0 as the loss only.
If we get
Y prime as 0, the serial number one for the point 0.
0, then the final loss will be 0, right?
Okay.
Like you
Or,
can take any linear operator between this, you will get 0. The loss for that particular linear operator will be 0.
but in the classification model, we only check the sign. So how the sign will be 0? Either it would be negative or either it would be positive.
No, we check for the indicator function, right? So if indicator function, if every f of xi is equal to yi, then all the indicator functions will become 0, right? See, this f of xi will give you the sign either +1 or -1, right?
Yes, sir.
Acha, you are saying that how come 0 comes?
Yes, sir. Yes, sir. Yes, sir. The opposite case of negative, opposite case of positive. What will be the case when we will get the negative?
Huh. So here sign, okay, maybe, so that is why I wrote the function first. So the function here maps the data points to either 0 or 1, okay? So how you have to define is, as we are going to use sign as our function, then you have to represent 0 to -1 and 1 to +1.
Okay.
Okay.
Yes,
So
sir.
if you are getting -1 for the sign, so that means it represents to 0. You should label 0 for it.
Okay. That's thing I was asking.
Okay. Yeah.
Yes, sir.
Okay. Got it. So that's how you have to represent. Yeah, if you do that, your loss will be, why the slide shows
0.25.
yeah, 0.25. And yeah, is this linear model good enough?
No, sir.
No, right? So what we can do, we can without initializing
So,
something like
how do we
point
decide this linear model is not good enough? Uh,
within this, we from the graph itself we can find better linear separators, right?
okay, got it.
Considering only
Actually,
these 4 points.
Okay, got it.
Because they are not separating any of the points. All those
Yeah.
points are all together. It's not actually separating any
actually, it
points.
should be in the first quadrant.
So
We
something
get
like this, and we can find better models by without initializing, like something like taking constant alpha x1 plus beta x2 plus some gamma is equals to 0. So this is our linear separator now, and using this and putting this into the equation, solving, you will get the better alphas and betas.
What is
And
a
where
good
you
model? What is a good linear model? What is the metrics to decide upon good linear model?
see, in the data, we will separate the data into training data and test
That's
data, validation data and test data. Okay, we will separate this. If a model works good in training data as well as the test data, that model is called, or maybe is a better model. And those models which works only on training data and fails miserably in test data, they are not good models. And models which even fail with training data itself is the worst models. So that's how we can actually separate the good versus the worst.
But here now what we have is just a linear equation and a graphical representation of the linear equation. Now with these two things you are asking, is it good enough? So from this, how do we really make a judgment, is it good or bad?
See, from here itself I can find better linear separators, and also whatever the separator I gave you, it's actually not separating.
You had given me an equation and we just fixed a line for that. So that's a very unique way of really classifying it. And now you are asking me whether it is good or bad.
This particular linear separator which acted as a model for us,
For
I am
the given
asking for
equation. For the given equation.
See, that is what, see, model is nothing but equal to this particular equation.
Okay.
Okay, so is this linear separator or the linear model is good for this particular data for classifying? Is
Okay.
it good or bad? What do you feel?
No.
For this particular data, 4 data points itself I am talking.
4 data points.
Like, is my linear separator doing something better?
That is the point I'm unable to decide. What is a good and bad here? No, that's what it
See,
is.
a
So
good
you are saying that this linear separator does not separate the data into two equal halves or two halves. That's why it is not a good model, because this equation is itself a model, right?
yes.
So it is understandable it cannot separate the data, so it is not a good model.
So see, that is why I started with what exactly is model. So you should understand what model is. So if I am
So can
talking
I say
always model, yeah,
that this model is not giving a representation for my data because it is falling outside my representation, the data inputs I have and the outputs.
see, first of all, understanding with very less data will always doesn't match to reality. Okay, just a second, just give me 1 minute.
Yeah, from my viewpoint, all the points whatever you are given is rightly represented, and all those points are falling on one side of the classification. So I classify that I reckon this one as a good model.
Actually, it should map with most number of points. That's the case we have answered in the lectures.
So most number of points are falling on one side of the line, no?
The 0 point, it is a red point, whereas the other points are a blue point. So they are different kind of point.
Yeah.
The separator which we have, the orange color, in that all the points are falling on one side of the separator. So it's telling the red and the blue, all of them are the same. Whereas that is really not the case. So this is not able to
It could be
separate
possible also, no? It can fall on one side of the classified zone. Does it
Sorry, I
does
didn't
it
get you.
matter? Does it matter if it is falling on one side is a bad model?
What we have to
Yes.
do,
Okay, so
maximum number of brown points should be in the brown region and maximum number of blue points should be in the blue region. That's how we
yeah,
will decrease loss. I mean, that's how the loss will be minimum.
The model which has the minimal loss will be the best model.
Yeah, we have only one loss, no?
Sir, can you speak? You were saying something about like how the models are made. So I think
so model is basically a mathematical expression. Okay, so there is no large difference between model and mathematical expression. So whatever you are seeing, that particular line is the model, which says above that above that whatever the points are there, that's the class 1. Below that whatever the points are there, it's the class 2. So I represented class 1 as blue class and class 2 as brown class. And what my model says is any point above this line is will fall under blue class. Any point below this line fall under class 2.
Hmm.
And my question is, our question is whether this particular model or whatever this line says, this model says, is
No, it doesn't show that way.
it doesn't show that, right? And that is why this is not a good enough model to say that anything above this line is blue and anything below this line is brown.
So
Okay,
okay. So
and the
that is
line which I drew, the next black line which you are seeing. So this line is again an equation, mathematical equation, right? This can be represented in some, maybe x1 plus x2 is equals to 0.5.
Hmm.
Okay, so maybe this is one model again. And what this line separates says is any points above this line is class 1, which is blue class. Any point below this line is a brown class. And whatever the data we have, the training data, so all 4 data points, if you put inside the model and compute the loss you will get is 0. Okay, if you compute the loss you will get 0, and which says that with by considering only these 4 points, this particular line x1 plus x2 is equals to 0.5 actually separated the 3 blue points and the one brown point. Okay, so it at least this x1 plus x2 is equals to 0.5 will work very good with training data. So that's for sure, right? Training data is these 4 points. But whatever the linear separator I gave, that doesn't work well with training data itself. It is giving me more loss compared to x1 plus x2 is equals to 0.5. Okay, so that's the point. So we can say, see again, yeah, whatever you are saying, I agree, Subramanian Mohan.
Yes, sir.
So good enough is actually it should be compared to something else, right? So that's your point. So yeah, so this particular line is not good enough because if I compare it with x1 plus x2 is equals to 0.5.
Okay, it's a relative.
Relative. Okay.
Right.
Sir, sir,
Yeah.
if a point lies on the line, then
On the line, it can be classified to any.
Yeah,
Either
it
you
would
can
be the
treat it.
same. It would be the same. Yeah, he was saying the consistent line, the consistent model, the line that represents the consistent model.
No, he's asking if a point is on the line which I
yes, sir.
represent. So you will get it as 0, right? Sign of 0 you are going to get. What will be the sign of 0? Usually we treat it as plus. Okay. Usually it's not
So it
defined.
will be blue then.
It's the
It will be
best case.
considered as blue point.
Here you can consider it as blue point also. Okay.
Basically, we need more data so that we can clearly say that this is a good model or not. In this 4 data point, we can't exactly say what is good and what
Exactly
is bad.
say correct. So that's the keynote I wanted to make. So we are taking very less data. Can I have? I am getting an echo. Okay. Still. Can I have everyone please be on mute? Yeah. Sometimes listening to their own voice will be what we can say. It is not good, right? No one tries to listen their own voice. Okay. So where am I?
Data points, sir.
So we take less data points to understand, first of all, and which doesn't match to the reality. Okay, so for suppose you treat like 1 point is equals to some 100 points. Okay, some 100 points somewhere. So you have to think about all this. So these many points are there in your data. So now can we do classification? Can we come up with a linear separator which separates these many points into two classes by getting very less number of blue points in the brown region and less number of brown points in the blue region by having? So can we do that? So that's the next step you have to think. Okay, so this is very basic thing. We take only 4 5 at max 10. Okay, at max 10 points, and we say can you come up with a classification model so that our training data will be very less in this course. And you should always understand that data will not be in tens or hundreds. Okay, data you are going to work in future will consist of some 1,000 rows and 10,000, sorry, 1,000 maybe 100 columns with 10,000 rows, more than that. Okay, so always you just have to extend from here to the reality. So don't try to bring reality into this, which will not work in general. With 4 3 4 10 points, if you wanted to see the realistic reality of the problem, it won't happen.
Sir, will we get a glimpse of these real world problems through this course? Not this course, but at least the diploma that we are doing?
You will get na. See, this is very ML foundations. Okay, we wanted to change the name of this by changing it to max and stats, advanced maths and stats kind of thing. So in machine learning foundations, you will get introduced to machine learning, and again you will be revised what all things you require before you get into that. That's what I told in the starting of this session, right? So it's like you ordered a biryani and you just open the cap of the biryani box. Okay, so machine learning foundation is opening the cap of it and just feel the aura of the biryani. If you want to eat it, then you have to be in machine learning techniques, machine learning practices. So that will give you the full satisfaction of biryani. So where biryani is machine learning. Okay.
So, will we able to deal with the real world problems after those courses?
Yeah, you have to do projects in that.
मम्मा को फोन बच्चे ये रख नहीं ये तो पता नहीं किधर है
Okay.
Okay.
Actually, in the week one tutorial sections, there were certain application based where
So I suggest you to go through the tutorial lectures. Okay.
yes, sir. So will there be just a kind of a data set to given to us such that we can also compute this simultaneously with the
Maybe we can work it out. Okay. So maybe
okay.
we will bring a real data and try doing. We will start from the scratch key. What kind of model we can impose on the data, and after that we can define an algorithm,
So
and
and so
then
that data is only basically just to tell to us that the scope of the subject.
ha ha.
Okay.
Yeah, we will try to get some realistic data to work on. Okay, so I will just make a note of this.
I don't think we have a project in MLF.
We do we no, we don't have project in MLF, but we can just give you that data so that you can work it out by yourself.
Okay.
Okay, so we will try. Okay, maybe we have TS, so we'll ask them to collect some data from somewhere
Sir,
on the
one more
site.
thing.
Yeah.
Sir, BDM and these classes are clashing. Live
No,
session.
right? Like only the first week got class. We came to know about this.
No, no, sir. It's on the next term also, on Saturday also, next Saturday. The BDM is from 5 and MLF is from 4 to 6.
Okay, maybe we will recheck. So whatever we checked in our calendars, so there is no session on Saturday at all. BDM.
Today, I guess from 5 of BDM.
Okay. This one first week only. They said they will have session, and from next week, we had our first session on Thursday, right? From next week,
Yes, sir.
BDM is going to happen on Friday. So it's not on Thursday next week. And maybe
But
I
it
think
is
they
there.
haven't updated in the calendar. It's
maybe
in
they
five.
haven't updated in the calendar, but we saw the actual calendar. So some students have complained in the previous session also ki, as a horror, and we just checked it, and only the first week is clash.
But it is back to back. So if you're not completing it by 6 o'clock, it is eating away PDSA.
Yeah. See that and all. See if see, we have only 24 hours in a day, right?
Mhm.
And we have more number of courses that should be. See, that is why we have in graph theory. So this is one application scheduling.
In fact, you should really announce the scheduling well before the course selection so that students can decide about the clashing is not disturbing their selection.
Okay, maybe I will take this as a note also.
Okay.
So I got two. Maybe one is the data, real data to work out some calculations.
Second is the schedule so that the students' selection of the
Okay,
courses can be helpful.
okay, okay. I just made the note. Let's move and let's discuss about this particular problem. Okay, now look at this graph again. So don't connect this to the reality. Again, I have only 4 data points. Okay, A, B, C, D. And there are 2 lines which are 2 models. Okay. And now I want you to recognize what type of ML problem is this.
Hi, Papa.
Regression. Regression, sir.
Hmm.
Say.
Okay. Okay. So can I put this in regression?
Sir, it is classification.
Classification.
It seems regression.
It seems regression. Okay. If it is classification, so how do you differentiate? So how many classes are there here?
So these points are not colored with different colors, so I think regression.
Oh.
Sir, as data is real, that's why I think it is a regression.
Okay. Okay. So yeah, see, by looking at this graph itself, it is very difficult to conclude that it falls under regression or it falls under classification. But as of now, I have 2 different models. One is green line and the other one is orange line. And in this particular or whatever, in this particular problem, I just want consider this as a regression model, regression problem. Okay, so if more data points are given to us, then it will be very easy to judge whether it falls under regression or classification. So as of now, maybe just believe me, or just assume that we are going to do regression model now, and our goal is to identify which line is the best or which model is the best, whether this is the best or this is the best. Which one is the best model? Green or the orange?
Sir, the orange one.
Orange one, because it's connected. It's just close, get close to most number of points.
Okay, close to most number of points. By looking at the graph, it looks orange, and you can also plot the points. No? So this is 1 comma 2, this is 2 comma 4, this is 4 comma 3, and this is 5 comma 5. So once you have the data points with you and you have 2 different lines, and what is the loss function for regression problem? So you just have to compare the losses, right? If I see this best or better, maybe I should ask better. Which one is the better? So in order to judge which one is the better, just compute the loss for green, loss for orange line. So which model has the less loss is the better model. And in regression problem, what will be the loss? So this particular loss we studied in maths 1-2.
It's the mean of squared error.
So it's 1 by n of some squared error.
Sir, but we need the labels.
Yeah, labels are given 1 and 2. The 2 is the label.
That is x2.
Which is x2?
Here, I think x-axis is the input and y-axis is the output, like the label.
So fx minus y. So what could be the y? basically.
Y is this output, right? See, the y-axis is the output, x-axis is the input.
Okay, sir.
Okay, so these are the two. See, if you simplify the lines, the lines will be like this. Like one is y is equals to x plus 1 and the other one is y is equals to 0.8 x plus 0.8. So if you just simplify that expressions, bada expressions, you will get this. And yeah, so by looking at the graph, some said green, some said orange. Okay, so by looking just at the graphs, it is slightly difficult to judge which one is better. So what we do is we compute the loss for green line, loss for red line, orange line, and whichever has the less loss, we will fix that. We will say that that is the better one. Okay, so just compute again. I will just write the loss function for you. So loss is 1 by n of summation I is equals to 1 to n, and I want f of x I. So this is one dimensional vector. Now I can simply write f of x minus y whole square. So this is the sum squared error, and total loss is mean of mean squared error. So yes, I will just give some 2 or 3 minutes. If required, I will give more time also. Just compute this. So how useful is ChatGPT?
It's really useful for general purpose.
Okay, and how useful is it for graded assignments?
Not yet attempted.
Okay. Has anyone tried using ChatGPT?
No, sir, I don't trust ChatGPT to solve graded assignment.
Okay. Even though you use it's not the wrong. It's not wrong, right?
Well, it helps in
Sir, but
programming
it's
assignments.
not supposed to do that, right?
It's not supposed to do that, but I can assure you, ChatGPT is very bad in mathematics. Okay, so it
So sometimes the calculations will be wrong.
yes. So ChatGPT may be good in other apart from mathematics. It is good,
So
but
we use it in coding Python.
Subramanian Mohan, can you please mute? I'm getting echo, or maybe can you use some earphones or anything? It does very good in general coding. Yeah, I agree. But for the computational part, it is too bad. Too bad. Even though you say you reply key you have done wrong, it again replies you key. It again replies you the same solution. So it is still under development. What we suggest you is please do not use ChatGPT for at least math stats and this machine learning foundation courses, because it will give you wrong answers for most of the time. Yeah. Okay. So what is the loss of green line? No one computed. Huh?
So we are computing just.
Okay, okay. So just take some time and I need answers. So what is the loss for this green and loss for this orange? Most of you who did stats to last term are in diploma now. Like, is that stats to you put it at the last and you did and just came to diploma? Is that how
Sir,
I
for
should?
Yes, sir. Yes, sir.
it's I have
Okay. Yeah, yeah. So why? Can I hear some reasons? So why did you do stats to at last?
comparatively difficult, sir, to understand and do assignments on time.
Okay.
so 0.69 for the orange one and the 0.75 for the green one.
0.75 for green one and 0.69 for the orange.
Yes,
So
sir.
those who are trying, just check whether this is correct or wrong. And I can see
Sir, I got
Prashant.
1.5 for green.
Okay. Some of them got 1.5. And I have seen some. Yeah, Prashant also told 1.5 he got for green. Okay. So, okay, maybe I will compute for green quickly. And we'll just move to the next question. And orange, you just compute. Okay. So I just need f of x and corresponding y values.
Yeah, it's 1.5, sir.
Okay. So let me compute for green. This point A is 1 comma 2. And C is 2 comma 4. This is 4 comma 3 and D is 5 comma 5. Okay. So if I see uh, my f of x is, this line is y is equals to x plus 1. Okay. For the first point A, my loss will be 0. So if you remember, you just put it in the table and you do all the stuff like x, y, and f of x. So x is from here, x are 1, 2, 4, 5. 1, 2, 4, 5, and y's are okay. 1, 4, 2, 5. Right, like this. So it is like A, B, C, D points. Okay. So A, B, C, D, 1, 4, 2, 5, and y's are 2, 3, 4, 5. And my model is f of x is equals to x plus 1. So in this particular line, I am trying to fit the data. And this will be 2, this will be 5. So it's like 1 plus 1, 2, 4 plus 1 5, 2 plus 1 3, 5 plus 1 6. So my loss will be 1 by 4 summation, or I will just go point by point. So for the first point, my y is 2 and f of x is also 2. That will be 2 minus 2 whole square plus 5 minus 3 whole square plus 3 minus 4 whole square. So it's like predicted minus actual or actual minus predict. It doesn't make any difference because we are going to square anyway. 3 minus 4 and 6 minus 5 whole square. So this is 0. This is 4, 1 and 1. So it's like 6 by 4. You are going to get 1.5. So this is for green. And similarly, this is for green line. And similarly, you just find f of x for orange line too. So orange line is f of x is equals to 0.8x plus 0.8.
1.6.
How much?
1.6.
Okay. Loss for orange 1.6.
No, 0.69. I
Yeah,
think
yeah.
it's entirely 0.6.
Okay. 0.69 you are going to get, and now between these two, orange and green, I can conclude that orange is the better one.
As it is approaching towards 0.
Orange model is better. So why this is better? Because the loss is lesser for orange compared to green. Okay, fine. So it's just very basic computations. Okay, so this is how it will be. Questions will be. So between these two, which one is the better one? And now consider this. So I have given a table, and I have in the table I have some multi-class classification problem. Okay, so now I said, as I discussed, the multi-class classification before. Multi-class classification is, it is classified into more than 2 classes. Okay, here I have 4 classes, 1 2 3 4. So these are the classes and these are the actual ones. So the left column is the actual ones and these are the predicted classes. Okay, what I want you is compute the squared error loss and 0 1 loss. So squared error loss is simply the difference square and sum it over, and 0 1 loss, so whether if those two are equal, the indicator function will show 0. If they are not equal, the indicator function will show 1. So it is, you just have to get fraction of misclassified. And which loss function seems to be a good one. So I want that also. So compute the squared error loss, compute the 0 1 loss, and tell me which one is good one. So these are these are the different points I have. Okay, so treat it like given data, predicted data. Okay, so now it will be very easy for you to do the problem.
There are 11 data points.
Yeah, 1 2 3 4 5 6 7 8 9 10 11. Yeah, 11. Yes, 11 data points you have. So as I told, this is the ground truth or the actual labels, and the right column is the predicted labels.
Sir, error is 4.72.
Sorry, Adarsh, are you asking anything?
I said, sir, error is 4.72.
Which one? Squared error or 0 1 error?
Squared error, sir.
Okay. So I asked two errors here. Squared error. You are saying that it is
4.72.
Okay, 4.72. And I also want 0 1 error.
0.3636.
0.36 is the 0 1 error.
Yes, sir.
Okay. So others, please check whether these errors are correct or not. If you are getting any other values, please let me know. We will just compute.
Okay, sir.
Okay. I'll give you some 2 more minutes, or if needed, I will give more. So those who don't know the difference, see, this is the thing I want. Squared error is basically the sum of summation actual label minus predicted label whole square, and 0 1 error will be summation indicator of actual label not equals to predicted.
If it is equal, it is 0, is it?
If it is equal means then we don't have loss, right?
Yeah, 0. Okay.
So shouldn't we also divide the summation by n?
Yeah, we can divide. We can also consider mean of it, but dividing by n is like, it's just you are just normalizing or fractioning it, right?
Yeah, yeah. Okay.
Sir, the 0 1 error is for my 0.54.
Okay, 0.54. Okay, let's compute then.
Squared error will be 2.36.
2.36.
Yes, sir, it is coming out 2.36.
2.36.
Okay. So let's see.
सर वॉइस इकोइंग a lot.
Huh?
Echo आ रही है बहुत ज़्यादा.
Yeah. Yes. Now it won't happen, I guess. Okay. So let us. So we got 2. Let's see the squared error why it is.
I got 2 as well, sir.
You got?
I got 2 as well, sir.
You got 2, is it?
Yes, sir.
Okay. So here they have divided by 1 by 11. So yeah, it doesn't matter. Even 22 or 1 by 11. It's just like.
Error, I think it is 26 divided by 11, not 22.
Yeah, it's gonna be 26.
It's going to be 26, is it? So let's see. So the first one is Subramanian Mohan, can you please? Okay, thanks. So actual minus predicted is 0. So 0 squared is 0. The second one is also actual is true. The predicted is 4. The difference is 2. But we have to square it. So that will be 4. And the same goes for the third, 3 minus 1 whole square, which will be 4. 4 and 4, 4 minus 4 is 0. 1 minus 4 whole square is 9. So similarly like this. So if actual and predicting are same, we don't have any error. So they all will be zeros. And only errors we have is this. So 4 plus 4 and 9 plus 9. So 9 plus 9 is 18. 18 plus 8 is 26. Correct. So it is going to be 1 by 11 of 26. And this will be 2.36. Correct. So this is the square error. And 0, 1 error is basically if they are equal, if predicting and actual are equal, there is no error, that will be 0. If the predicting is not equal to the actual, then it will be 1. So just put zeros and ones like accordingly. So it will be 0, 1, 1, 0, 1. So 1 because 1 is not equal to 4. And 0 because 2 is equals to 2. So 3 is equals to 3, 0. So like this, we will have 1, 2, 3, 4. 4 ones out of 11. So 4 by 11, which is 0.363. So we say 36% are misclassified. Okay, that's how we will represent the error.
Sir, how to represent some squared error in percentage?
It will be, but some squared error. Okay, maybe you can talk like this. Maybe
How far
no,
the
so
points
that
from the line, like that?
No, we can't say, because see the point is, with if this is squared error, right, the distance can go till infinite also. See, this is just the difference. Okay, sorry, distance. So the squared error is basically computing the squared distance, and this distance, we don't have an upper bound for this distance, so it can go till infinite also. So if I wanted to represent it in fraction, saying 2.36% of the data points, or no, we can't, man, we can't. Maybe I am missing something in that. If we can, I can just check back and I will get back to you. Okay, as it is
Sir, I have a
related
doubt.
to distance, it cannot be represented in that way.
Like sum square or mean square, I understood for regression,
Hmm.
but for classification,
Hmm.
so let's say if we are classifying into labels,
Hmm.
and then we're numerically coding it, so sum square errors will only like exist if like difference of two labels can make sense, right? So if subtraction is defined on the value. Let's
Ha.
say I'm just classifying from some metrics, I'm classifying whether the person is male or female,
Hmm.
and I'm assigning 1 and 0 arbitrarily.
Hmm. Hmm.
So there, the difference won't make any numerical sense,
Sense.
right?
Yeah, correct. See here, this is a classification problem. Okay, and in classification problem, using some squared error loss, like squared error loss doesn't make sense. Squared error loss is basically gives us the how far a data point is from the actual, or
Yes,
sorry,
yes.
predicted, like
It will only work if a distance function is defined on that.
yes, correct. But just for computation part, we just ask what is the squared error loss. But I agree, it doesn't make sense on classification problems.
Okay, sir. Thank you, sir.
Yeah. Okay, but this is how we compute square. If they ask for squared error, you just have to do this. If they ask for 0, 1 error, you have to do this. Now the last question is, which loss function seems to be a good one? Now tell me which one seems to be good one for this classification problem. Which loss function seems to be a good one?
The 0 1 loss.
That's quite different.
Huh?
0 1, sir.
0, 1 because of the problem, as well as if you see, these are just the labels. Okay, because of the problem. See, this is a classification problem, and if you are looking at the squared error loss, you are getting 2.36. What will you get from that? So what will you infer from that? 2.36. So labeling 2, actual label is true, but predicted 4. Does it make any difference if I predict 3? Error is an error, right?
Yeah.
The label, if it actually to be labeled 2, if I label it 1 or 3 or 4, all 3 are same because it is not labeled 2, right? So that is why in this particular classification problem, 0, 1 loss is a better function, better loss function than the squared error loss. Okay.
Yes, sir.
Okay. So let's move to the final question I have. Now consider an encoder matrix and a decoder matrix, which are given below. So these commas are given only for your understanding. Okay. If I have to represent this, the matrix format, this is how it will be. And the same goes, this is the transpose of the W. Okay. Now what I want is you have to compress this particular data point, which is given to you like 1, 2, 3, 4 whole transpose to obtain some U. So you are compressing X to some U, and again you have to reconstruct X prime from that particular U. And also I want you to find the loss or the reconstruction loss. So what is the loss happened during this encoding and decoding? So what kind of a model is this, like, or these functions, encoder, decoder,
Dimensionality reduction.
dimensionality reduction? And can anyone tell me the prime use of dimensionality reduction? Why do we try to fit data into this dimensionality reduction model?
So
Sir,
for
for faster
simplification,
processing.
We can represent more numbers
To
in
reduce
the
storage size.
To reduce
to
size
compress
for
the data
transmission of
or
data.
Yeah, to compress the data. Okay.
to
So if
group the data.
Okay, I agree. If I have some 1,000 features, okay, and some 5,000 rows of data, and all 1,000 among those 1,000, all may not be important features, right? Like we can have 1,000 features. Like for example, you are just predicting the same example. You can take predicting the house rate in a region in Chennai or in somewhere in Delhi. So there will be lots and lots of features. Not that the number of rooms. So these are whatever the professor has explained in the lecture. They are only 1 or 3 main fact features. Along with that, you will have multiple features like: is there any hospital nearby, amenities nearby, is it this it depends on the region. So is it far from city, is it nearer to the city, uh, or how far is it from railway station, bus stand? There will be many features which you can compress those features into main features. So yeah, just like the tweets also. So you have seen, you will get millions of tweets on Coca-Cola, right? And you have to group that into um, that millions of tweets into some 10 groups. So one group maybe say they are praising the bottle shape, and one group is praising the taste. So shape, taste, color. So all these will be the features. who like to compressing the whole million data into some shorter dimension, and again this shorter dimension should again go back and represent the larger features. So there this dimensionality reduction. So that kind of problems we will be interested to use the dimensionality reduction. So what will you do if 1,000 features are unique, different, and equally important? So you cannot do dimensionality reduction there.
So basically, dimensionality reduction is kind of like choosing the important features, right?
Like it's
If you have a good
if you
encoder,
have if your data has more number of features and you can reduce the features and inside another feature, so we will do this right dimensionality reduction.
it's like if some features are like not important or redundant, to be
Maybe
considered.
not that important to be considered. Like this you can reduce, and even though you do it out back, you won't get much loss.
Hmm. Okay, sir.
uh, so listening to the history of dimensionality reduction, what happened to this problem then? So okay, if I have given you the encoder, what will you do that encoder?
I will multiply the matrix with the vector to get
Correct.
the like encoded.
To get the u, what I have to do? I have to
W
multiply
times
w to x, right? I will get u. So what will I get if I do that?
1 and 2, like first row 1, second row 2.
Yeah, right. So it will be 0 0 0 1 0 0 multiplied with 1 2 3 4. Okay. So this will be 1 times 1, 0 times 2, 0 times 3, 0 times 4. It will be 1 plus 0 plus 0 0. It will be 1. And the next row is 0 times 1, 1 times 2, 0 times 3, 0 times 4. So it will be 2. So you are going to get 1 comma 2 whole transpose for the vector 1 2. Okay, column vector 1 2.
Sir, why did you multiply that two vectors? Where is the encoder saying that you have to multiply?
See, encoder functions, what we will do with encoder, if you have encoder with you and a vector with you, a data point with you, in order to reduce the dimension, see this encoder, what this encoder does is, it will reduce the data point dimension from 4 to 2.
So why did how come it is multiplied? I didn't get.
Uh,
Why did you multiply the two matrix?
why did I multiply? Because in order to reduce the, see, okay, see you have studied this linear transformations, right?
Yes, yes.
So in order to reduce the dimension, what will you do there? You take a matrix, you will have a t multiplied by x. You will have a transformation which will be multiplied by some matrix, and it will give you something else, right? Okay, just leave it. See, I have a data point which has 4 features, okay, and I want to reduce the dimension to 2. What should I do to the okay, maybe vector is nothing but matrix. What should I do to that matrix so that the dimension of that matrix will reduce to 2? Okay, I have a vector which is 1 cross 4, sorry, 4 cross 1. Okay, so 4 cross 1 data I have, and I need after reduction, I need it to be 2 cross 1. What should I do to 4 cross 1 to get 2 cross 1? If I add some other matrix, will it shorten to 2 cross 1?
No, I think so.
No, right? So what
Yeah.
should I do to the matrix 4 cross 1 to make it 2 cross 1?
Yeah, I think we need to multiply only. So
So that is the encoder. So what this encoder matrix will do is it will get multiplied to the data point, and by multiplying you can reduce the dimension, and you cannot get that, you cannot achieve by adding or subtracting or any other things.
okay.
Okay. Yeah. So now if I have to reconstruct back, what should I do? So I want x prime again.
Will multiply with the decoder matrix W
Yeah.
transpose.
So now x prime should again I want, now I want, so I have two cross one matrix with me, and I want 4 cross 1 matrix. What should I do?
Multiply W transpose.
Yeah, 2 cross 1, I need 4 cross 1. So with what should I multiply? I should multiply with 4 cross 2. Correct? 4 cross 2 matrix. Then it will get multiplied to this, and I will be getting 4 cross 1 matrix. So 4 cross 2 is like this. It will be like this, which is given to us again. So I have to multiply W transpose to this U to get the x prime. So if I multiply, what will I get?
1200.
This should be multiplied to 1 2. And what am I going to get? It is 1200. Correct? Is this correct?
Yes, sir.
Yeah. So now if you observe, we started with the data point 1 2 3 4, but we reconstructed x prime by using this encoder decoder functions. We have reconstructed this x prime, which is 1200. So both are definitely not equal, right? And I asked you, how close is this reconstruction to its original? So how do you measure this closeness?
By taking the dimension.
By taking norm square of error
Correct.
difference.
Correct. So if you wanted to measure closeness between vectors, it is always recommended you to compute the norm difference. So you take the difference of this vectors
Error
and compute the norm, error vector. So the difference will be the error vector, and compute the norm of that vector. So norm, I refer to norm as Euclidean distance, okay? So, or L2 norm, we call it as L2 norm. Okay. Euclidean distance means like this. So the norm of any vector, we take the square root of x1 square plus x2 square plus xn square. So this is the Euclidean distance norm. Euclidean distance, or we simply say L2 norm. Okay. So in this
So
particular
what does
course,
L2 mean in this?
L2 is like we are taking the square root and square. It's like Euclidean distance. L2 means each and every term will be squared and taken the square root.
Okay.
Okay. So like this, we have L1 norm, we have supremum norm, which is L infinite. So you don't require all this. So norm means it's the distance, okay, and in that this Euclidean distance is referred to as L2 norm. And we, in this particular course, whenever we say norm, that refers to Euclidean distance only the L2 norm. We are talking about only the L2 norm, nothing else. So remember, a norm of x is defined like this. Now what is the error vector?
0034.
0 0 minus 3 minus 4 or 3 4. Let me take
Minus
x.
3 minus 4.
Minus 3 minus.
Okay, that is why if you use this Euclidean distance norm, it will vanish off. Whether it is 3 4 or minus 3 or minus 4, it will, anyway we are going to square it, so it will become, so I have the solution, I guess. Yeah, so you see, so u will come out to be 1 2 and x prime will come out to be 1 2 0 0. So the closeness is measured using the norm. So this closeness means compute the norm of error vector. Okay, so this is the error vector. So this minus this will be the error vector, and if we compute the norm of 0 0 minus 3 minus 4, we are going to get square root of 0 square plus 0 square plus minus 3 square plus minus 4 whole square. So what will this be? Square root of 25, which will be 5. So the norm will be 5, norm squared. So the loss, so usually we are going to represent in dimensionality reduction. So the loss is represented as square norm. So we are going to look at the squared norm. So it will be 5 square, which is 25. Okay. So see, from week 1, what you have to, the key takeaways from week 1 is, so you just have to understand what machine learning is basically. First of all, you just have to be used to the terminology of machine learning, and then the different, the main classification of machine learning or the paradigms of machine learning we have. So one is supervised learning and the other one is unsupervised learning. So understand what is supervised learning means, and what kind of models will fall under supervised learning, and what kind of models will fall under unsupervised learning, and just know basic uh, understanding of each of the models. Okay, so what whenever we say regression model, you just have to understand that regression models are used to predict data, and regression models are very much used if the output is a real output, continuous real output, and these kind of small features you just have to recollect whenever we ask you about regression model. And there are many examples we have given in activity practice, even in graded also we ask like what kind of model is fit into this particular situation, like this. So just go through all of them, and even on online, even in online, if you find any situation or data, just try at least uh, to guess what model will fit into that data. So that's the prime takeaway from this week. So you just have to identify whether this can be put, whether regression model can be put onto this data, or classification, or something density estimation, or dimensionality reduction. So these are the 4 main models we discussed in week 1, and on top of it, this computation, small computation. So whenever regression is used, what kind of loss function is a better loss function to be used for regression model? So what will be a better loss function that can be used for classification model? Similarly, for dimensionality reduction, what should be the loss function? How should I define my loss function? So loss function also plays a equally important role as the model you fix. So once you fix the model, and defining your loss function also plays the equal importance role. So just now we have seen couple of questions, so maybe the previous question. So if it is a classification problem, if you are using squared error loss, that doesn't make any sense. Okay, so these are the two prime key takeaways from week 1. And from week 2 we will again go back to mathematical concepts and statistical concepts, and in between there will be few uh, machine learning terminologies also we are going to learn throughout this course. And again, this is just the foundational course of machine learning. This will again refresh your mathematical and statistical skills again. And yeah, so
Sir,
that's
is it okay to only follow the lectures and the practice assignment and graded for getting good hang on MLF, or is it necessary to follow some other books also?
right now for linear algebra, at least instructor Karthik has created one GitHub page. Okay.
Yeah. I think it is already mentioned in the forum. So
Okay. So you can just follow for a linear algebra part at least for that notes, and see anything everywhere. Okay, it's not that always what we provide you. So we cannot see. Machine learning is not what we teach you in this 12 weeks. Correct. Right. Like
yeah, that is for
uh,
everything, na sir.
right. So that.
Everything is application only, basically.
Mm-hmm. So what I suggest you is, so use, see, right now we have access to internet. Okay, how much uh, knowledge you wanted to gain, just gain it from the internet. So just open any Google and type some problems on machine learning or whatever. So along with this course, if you find time, if you got some time, just open Google, or even ChatGPT will give you good questions. Just ask ChatGPT to give you some questions on this topic or that topic, whatever the topic you feel. Even ChatGPT will give you many problems. So along with this, I always recommend everyone, if you got some time, doing this course will give you grades. Definitely will give you grades. So just following these lectures, practice assignments, and uh, solving graded assignment mocks will definitely give you marks for quiz 1 and quiz 2, and definitely a good grade. But my point is, you should not always run behind grades. Rather, you should also look at gaining knowledge, okay, in this particular process, through this process.
Sir, one more question actually. In my foundation, the grades did not change much. So if now we are like how to get the grades better off?
Okay.
Because
If you are worried more of grades, then definitely I recommend you just join the live sessions. Definitely not all the live sessions, but I recommend you to join for at least the revision sessions and the mock sessions. Along with that, follow this practice assignment, graded assignments, all this practice graded tutorials. And yeah, so, and never be like, just read. If you're reading today for some 2 hours and you're giving gap like some 3-4 days, and again you start looking into the content, never leave the grip of the subject. So it's like you should follow the course daily, or if you missed one day also, it's fine, but you definitely have to come back in the next coming day. Okay,
okay,
you should not leave the grip of the concepts, then you will
okay, sir.
definitely get a good grades. Yeah, Prashant.
Sir, the supervised learning is same as that.
Same as, sorry. Okay.
Predictive models.
In supervised learning, we supervised learning is basically kind of curves fittings. Okay, so we have some data and we try to fit that data. So well labeled data we have, and we can find some curves which uh, more or less fits to that particular data. So this is what supervised learning is. And Usually predictive data models will fall under this supervised learning. Okay, Ashitwa.
Yes, sir.
Yeah.
Sir, in this last question, why are we using square of norm as uh, loss function and not mean of squared errors?
So that is what I told you, right? It's not always you find the model, perfect model. It is also equally important that what kind of loss function you assign to this decode. See, it is not squared error because squared error is basically f of xi something. It is between real numbers, right? So
Yeah.
one real minus another real, you just square it. But when you when you come to the dimensionality reduction, so the output is not real. Output is a vector. Okay. So how do you define the squared error among vectors?
Okay, sir. Okay.
Right? You understood, right? If you are
Yeah, yeah,
using
yeah.
squared error as the loss, then you can't subtract one vector and other vector and square the vector. How
Yeah,
can you
yeah.
square the
We
vector?
can use it for real values or some like
Right.
because in this there are vectors like it's just like compressing the vectors into a smaller unit. So it should be like yeah, got it.
Got it, right?
Yeah.
So that is why. So defining your loss function is also plays the equal importance.
Yes, sir, yes, sir. Got
Okay.
it. Thank you.
Yeah, yeah. Thanks. Sankara Rama Subramanian.
Yeah,
Yeah.
it's basically.
Yeah.
Sri, like it's a general doubt, Sri. Yeah.
Mm-hmm.
Just want to confirm, like, when can we expect the foundation certification? Like we already completed, we have to do the standard. Just to
Foundation
check, like,
certificates. Okay. So you haven't, you
just,
didn't come to Paradox, is that?
yeah, right, that's correct.
Maybe they will post. It might take some 1 month, right? Like,
Similar to like we can able to download from the documents
okay.
from.
I just don't want to give maybe wrong answers for this. Uh, I don't. Can you contact support regarding this? I'm not sure about these things. Okay.
Fine,
Also,
Sri.
I don't want to comment on this quickly.
Sure. Thanks.
Yeah. Yeah,
Thanks, sir.
Prashant. Thanks.
Sir,
Hmm.
so we use regression model to find if the labels are discontinuous, sir.
It's yeah. It's not label. Then it will be like output. So we call it as an output. If it is continuous, we use regression model, and
Yes,
the
sir.
output is also continuous real values.
Yes, sir. Because for finding the steps, number of steps, we use regression model, sir.
Hmm.
But that is not continuous. It is discrete, sir. Steps cannot be in point decimal. Sir.
Which one? Which one?
The first question, finding the number of steps.
Steps. See, steps cannot be in reals. I agree, but you see when the steps can be from 0 to infinite, right?
Yes, sir.
Right. Like hypothetically, he can walk like infinite steps, right? Like there is a chance, right? Now the outputs is not it is discrete, but see if you see it's like the range is infinite. Okay. And regression, why regression is because none of the other models can be best fit into this. So you can't do classification. Correct? Prashant, are you there? You are on mute. Am I audible?
Yes, sir, you are audible.
Okay.
Yes, sir.
Yeah. So you can treat number of steps as in this particular
Sir?
case you can treat it as continuous. It's fine. It's okay to Also, you can see none of the other models will fit into this kind of situation. Okay.
Okay, sir. But if the output is in decimals, then we have to approximate it.
Approximate it to?
Approximate to the discrete number, round value.
Not always. See, in regression, you can always get outputs also, output also something like 0.5 or any real value you can get as an output. Okay. In the first question itself, we have seen our outputs are natural numbers because of the situation.
Predict makes sense.
Because of the situation. And for that particular situation, you can't even do classification, you can't even do dimensional. There is no point of talking about dimensionality reduction and other models. So but you can treat the number of steps as continuous. See, 1 after 2, 2 after 3, 3 after 4. So you can treat it as continuous data and then work it on regression. And yeah,
because we cannot use classification, there will be too many classes.
Right. So the other models will not definitely fit. Okay. Yeah, so most of them have shared the GitHub page, and also YouTube link has been updated in the calendar. I just updated it now. Okay. So I will just stop the streaming and we can meet in the next week. So from next week onwards, again, you will see functions, limits, continuity, differentiability, derivatives, linear approximations. Okay. And then you will see again parameter estimation, hypothesis, testings, all this. In between, we will also see new topics called SVD and positive definite and many things. But again, you will be in maths and stats world only. More of maths and stats world. And yeah. So that is how MLF is going to be. And yeah, I hope we will definitely have a good term this time. And yeah, Prashant.
So maths and statistics both will be equal, sir, or maths content will be more?
Maths will be more, I guess. Stats will only come at the end, like last 2-3 weeks.
That for probability.
So we'll start from again total of probability. From there we will start and we will end with hypothesis.
From week 10. Sir.
Yeah, week 10, 11, I'm not sure. Week 10, I guess.
So before that, there is no stats content.
No.
Okay,
We will be seeing again maths. More contents are mathematics. Are from mathematics. Okay then.
Okay, sir. Thank you.
Thank you, sir.
Bye, guys, and yeah, we will
Bye,
meet
sir.
next week.
Thank you.
Yeah. Thanks.
Thank you, Sri sir. Thanks a lot.
Thanks.